Let's look at the central limit theorem for averages. This tells us that sample averages x bar follow a normal distribution with the center of mu and a standard deviation of sigma over the square root of n. So I use this model for looking at averages. So if I have a problem talking about sample averages, this is the model to use. In particular, it goes from population mu, and it tells me what to expect for a sample x bar. Let's look at an example. Now, typically, you need to have a large sample size to use the central limit theorem, large meaning 30 or more samples. This particular problem only has 6 samples, so that seems like it's too small. The backup for large N for the central limit theorem is that it starts out normally distributed. So even if this feels like too small of a sample to assume something is normal, we're in okay shape here. Okay. It is claimed that the average length of a commercial for a YouTube video is 72 seconds. So population average for all commercials should be 72 seconds. Now, not all YouTube commercials are this long. Some are those 4-minute manifesto things that they force you to listen to. Other ones are just like 15 quick seconds. So these vary a lot. The standard deviation is 15 seconds. And knowing this, how likely would it be to have 6 independent commercials last 8 minutes or longer? So I am looking at 6 commercials. And the question is, what is the probability that the total for the 6 samples is 8 minutes or longer? Now, a bit of an issue. I'm noticing that my units up here are seconds. This is in minutes. So let's rewrite this 8 minutes into seconds before we try to do anything. I'm remembering that there are 60 seconds in a minute. So if I do 60 times 8, this is really the same thing as saying, what is the probability that the total for the 6 samples is 480 seconds or more? Just converting minutes to seconds. Now I have a second issue. Now I would say the second issue is actually bigger than the first one. This is a question about totals, but this model above only knows how to answer questions about averages. So just as a note, should you have a question that you want to rewrite about averages and it's about totals, to find an average, you add all of your numbers together and you divide it by the number of trials. In other words, if I wanted to rewrite this total as an average, I could do so by dividing by the number of samples, 6 in this case. 480 divided by 6 tells me I'm looking at the likelihood of an average length of 80 seconds or more per video. This is now matching up with the distribution above. I can use the central limit theorem to answer this thing. So sometimes I have to do a little bit of prep work before I can use these models, but that's okay. So my model to answer this question will be x bar, and I'm leaving this as is because this is telling me the type of question I'm dealing with. It's an x bar question. It's normally distributed. This means that when I draw the picture, it's going to look like a bell curve with an average of mu, that's my 72, and standard deviation of sigma over root n, 15 over square root 6. So let's plug in those numbers. Average 72, sigma of 15, and a sample size of 6. Typing that 15 over the square root into my calculator, this gives me 6.124 or so. So drawing out my picture, the center of my curve is 72. And when I'm counting, I'm roughly counting by 6 or so. So this is roughly 78. This is roughly 66. You can use more decimals if you want. I'm just trying to come up with a really rough picture of what's going on. and I want 80 or more. So what I'm going to do to answer this question based off this model is I'm going to find a z-score, and then I'm going to look this thing up either using technology or using a table. I find z-scores by taking the value I care about, in this case 80, minus the center, in this case 72, divided by the standard deviation. So this is always going to be your value minus your center divided by your standard deviation. And when I type this into my calculator, I end up getting a z-score of 1.31 or so. So this is the point where if you normally use technology, look this z-score up using GeoGebra or whatever you happen to use. I'm going to look this 1.31 up on a normal table. And I'm going to find where the 1.3, those are the first two digits of the z-score, meet a 1, and that looks like it happens there at 0.9049. This represents the entire area to the left, my picture shaded to the left. So if I want this area to the right, I'm going to have to do 1 minus this table value. And 1 minus this 0.9049 gives me a probability of 0.0951. Now in context, this means there is a 9.51% chance that 6 commercials last for 8 minutes or longer. The central limit theorem is unique in that it's the only distribution we've seen so far this term that can deal with sample averages, and it can deal with problems involving units. So this is a great tool to have in our tool belt.